So we've seen what happens in a straight mirror. The image, you got to take two rays off of here, and you'd see where the reflected rays go. The reflected rays extended back will cross over at a point where the image on the other side of this mirror showed up. Let's move over and say, well, that's fine. Let's go to a curved mirror then. What I have is a curved mirror here, and I've drawn in a big green line an example of what a curved mirror is. One of the things that's true about a curved mirror, it's got a property, right, that if you take the radius of this circle, let me just draw it right in here, okay, that radius that is drawn around, that's going to be a defining point. We're going to need that for a lot of calculations. But that line that goes from the middle of that curve all the way back, that's going to be called, that has a special name, that's the principal axis. And that's going to be true of any curved surface. We're going to see in lenses, we're going to look for a principal axis. It's the line of light goes through the center of the body of the center body of the lens. That's the principal axis, and I just want to draw that in there. Now, the other thing that's true is if this is a radius and it goes out to the circle, that is the normal to that surface. It's coming 90 degrees back from that surface. So if I put the mirror back in here, what do you suppose is going to happen with the reflected light? As long as I'm on here, let's go, and I'm going to just let you see as I come in. Here's the incoming light as it goes up right along that surface, and I can see right here, here's the image, and I've almost got it pointed along there, so I'm going to turn it just a shade. So as it comes in, I can see it on my pen here. And then if I go down a little bit, I'm going to see that the image, this light comes back. I'm looking on this side now. Okay, it's coming right along here. Oop, I gotta go the other way. There we go. Okay, so it's right in the middle. So here's my incoming ray, and here's my exiting ray. All right. Now that's always one of the rays we can take. We can take that ray through here, and here's the center of that circle. That's the point. We're going to call that C, the center, okay, of that circle. We also have another rule that if another line that comes parallel to the principal axis, that comes in, for instance, and it hits the mirror anywhere, okay, where do you think that light is going to end up going? If I hit that there, any guesses? It's going to hit here. And it's not going to go to the center because the law of reflection says here's the normal. You know, the normal is that line from the center to the mirror. So it can't hit there. And if it hits this right at that point, let's make that actually happen here. The rule is that this has to then bounce at the same angle, right? These angles have to be the same. So this is going to go through a very special point, which also hits the principal axis and comes this way. Well, I could try it again over here. If I have a line that's coming in, hits the corner of that mirror. Remember, here's the radius, so it's got to have a reflection that equal amount to come through here, and that's going to make it come down through. And you're going to notice that all these lines cross at a single point. That point where a circular, part of a circular mirror, or cylindrical mirror crosses, this point has a special name too, and that's called the focus. That's where all the light gets focused. Okay, and usually they'll give that the symbol F for the focus. This is the center of the radius of that curve. That's C, the center. So we've seen two rules. If a line comes in through the center, because it's the normal, it's going to reflect back along the center. If a line comes in parallel to the central axis, when it goes out, it's going to go through the focus. Now, the inverse of that rule is also applicable. If you send a ray through the focus and it hits the mirror, if it goes through the focus and hits the mirror, it's going to then go out parallel to the principal axis. So that's the third kind of rule. You can go through the center, it's going to come back along the center. If you send it through the focus and it hits the mirror, it's going to go out parallel to the principal axis. If it comes parallel to the principal axis, it's going to go through the focus. So that's the rule of ray tracing. These are ray tracing rules for, of course, the light goes out because I'm filming.